So in this module 6, we will be studying uh, support vector machine in the first part of it, which requires you all to know about hyperplanes. What is a hyperplane? What is the separating data with maximum margin? So what is a margin? What is maximum margin? All of that. So we'll study that those terminologies before we dive into uh, support vector machines. So support vector machines are considered by some people to be the best stock classifier. By stock, what does it mean? It means not modified. So data taken as it is. This means you can take the classifier in its basic form and run on the data, and the result will have low error rates. Support vector machines make good decisions for data points that are outside the training set. So I've been taking some this references from the book of Peter Harrington, and whichever book I have talked about, I've just mentioned at the end of the slide, so that you can just refer to those books. Okay. So to start with, we'll understand what is a finite dimensional vector space, what is hyperplane, what is linear separable data. So what is a finite dimensional vector space? What is a vector? Vector is a collection of positive integers, a collection of numbers. Okay. What is a vector space? A set of all these vectors in an n-dimensional vector space. N-dimensional vector means an ordered n tuple of real numbers of the form x1, x2, x2, x3, so on till xn. And to denote this complete thing, x1, x2, x3 till xn, we denote this vector by x with a arrow up over it. The coordinates of this vector x are x1, x2, x3 till xn. Or we can say that the components of the vector x are these. Okay, and these are actually also called as features. So I just pasted what in my writing. I'll explain you what it is. So number of features. How many number of features are there? So what are the features? Data set is a collection of samples. You agree to that? And each sample is represented by certain features. Some data is there. So a data of a person is there. The height is there. Weight is there. Age is there. So these are the three features, isn't it? So if you are only taking one feature, the number of features is one, then what do you say that it is a one dimensional thing, right? You're dealing with one dimension. For example, it is weight, suppose. Now, how do you represent it geometrically? Geometric representation would be a line, isn't it? The weight of a person could be a small baby, it's maybe 2 kgs, 3 kgs, whatever, and it maybe go to around 120 kg, maybe a very overweight person. Huh? So it is linear. You can just use a line to represent it, isn't it? एक लाइन बहुत है समझने के लिए इसको, isn't it? This line is enough. So one dimension is enough to represent one feature. Okay. Now, if you have two features, suppose you have a height as well as weight, you say that this is two dimension. To represent two features, you require two dimension, and for that, maybe you need a plane like this. So you need an x-axis, you need a y-axis. On the x-axis, suppose I am having the weights, and on the y-axis, I am having the height. So now you can plot this point. So this point could be the weight of a person who is maybe 50 kgs, and height of a person could be some 150 inches, something like that. If you have got three features, then it is a three-dimensional case, isn't it? So you have height of the person, weight of the person, as well as the age of the person. Now, how do you really see it in geometrical representation of it would be something like a cube. So you have the weight on the x-axis, you have the height on the y-axis, and maybe you have age on the z-axis. So then you are having this cube. So this point somewhere over here may be of a person who of a particular weight, a particular height, and a particular age. Now, if you have n features, we say that it is n dimensional. So now we have how many attributes here? X1, x2, x3 till xn. Okay. So how do we represent this? For this, we have n-dimensional vector space. It is very difficult to visualize it. So we say that it is an n-dimensional vector space that we are using to represent this data. And this is what is called a vector. Okay. This is what is a vector. So a vector could be two features, three features, five features, or even one feature. Okay. If data set has n features, then vector representation to represent data set uses r raised to n. So vector representation to represent data set, we use r raised to n. So here if it is one dimensional, we say r raised to 1. If it is two dimensional, we say r raised to 2. If it is three dimensional, we say r raised to 3. And if it is n dimensional, we say r raised to n. So an n-dimensional vector means an ordered n tuple of real numbers of the form x1, x2, x3 till xn. We denote it by a arrow over the x, no? A vector by arrow over the x. Vector space क्या है? A set of all n-dimensional vectors with all possible operations on the vectors, or n-dimensional vector space, which is denoted by r raised to n. Now, there are certain terminologies which you need to know when we deal with these vectors. Okay, so what are the operations that you do on these vectors? Is something we'll just see some terminology. Suppose a norm. What is a norm? The norm of an n-dimensional relation. So if x is a vector with x1, x2 till xn, the norm is denoted by double bars like this. X raised to x, which is having an arrow over it, and then double bars. This is what is a norm. And what exactly is this norm? This norm is actually the distance from the origin of the vector. तो क्या सपोज कीजिए कि ये पॉइंट है, दिस इज द पॉइंट दैट यू आर कंसिडरिंग. सो नॉर्म ऑफ एक्स बार इज what is x vector? X vector is suppose having two attributes only, x1 and x2. Huh? X vector is suppose having only two attributes, two features, x1 and x2. And if you want to know the distance of this particular vector point x from the origin, then this is what is called the norm. And distance from the origin to this particular vector x is what is the norm. Origin is where? Over here, 0, 0, isn't it? So if suppose over here till here the coordinates for it is x1 comma x2. So if you really want to find out the distance here, you can find it out, isn't it? The distance is the hypotenuse of this right angle triangle. So what is this distance? This is x1. What is this distance? This is x2 distance. From 0 it is coming. So it is x1 minus 0. This is x2 minus 0. What is the hypotenuse? It is square root of x1 minus 0 squared plus x2 minus 0 squared. And you are just finding out the square root. And suppose there were more vectors over here, x1, x2, x3, x4, x5. What you would have done? You would have just repeated this for n number of vectors. So you would have got x1 squared plus x2 squared plus x3 squared till xn squared and a square root of it. So this is how you find out the norm of a particular vector. And norm means what? It is the distance from the origin to that particular point. I hope this was understood. Okay. There is something called an inner product. The inner product, suppose there are two vectors, x and y are two vectors. Okay. X is having features x1, x2 till xn. Y is having features y1, y2, y3 till yn. Then if you are doing a product of these two vectors, then what we do is x1 is multiplied by y1, x2, y2, x3, y3, and xn with yn. So this is what is called the inner product of the vectors. Now there is a term called a hyperplane. What is a hyperplane? A hyperplane, an n-dimensional space, is a flat n minus 1 dimensional subset of that space that divides the space into two separate parts. So suppose if you are having these vectors scattered on a in a space which you are wanting to separate. So if it is a line is a hyperplane in two dimension space. A plane is a hyperplane in three-dimensional space. What is a plane? Itself, plane is two-dimensional, isn't it? What is line? Line is itself one-dimensional. So line is actually used to separate a two-dimensional space. A plane is used to separate a three-dimensional space. So what is a plane? N minus one, isn't it? Line is n minus one. So let's understand what it is exactly. So it is saying that n minus one dimensional thing you require to separate the spaces. What does this really mean? So let's look at this again. So if you have got one feature, number of features is one. Number of features are one. You are dealing with one dimension, right? For example, in one dimension, you have just the weight of the person. Okay. So you are using a line to represent, isn't it? So now if you want to separate, suppose if you want to separate, you have an people who are low weight or and high weight, something like that. So how will you separate it? Now what are the weights? 0 to 120, isn't it? We have made. Now I want to separate. So how will I separate? Now to represent one dimension, I require a one dimensional line, isn't it? To represent it. But to separate the two groups, I need a point. A point is what? A zero dimensional, isn't it? So point is a hyperplane which is of zero dimension. So for one dimension, I am requiring zero dimensional hyperplane. For two dimension, I'm having height weight. So क्या है? इस तरह से you'll have to geometric representation is like this, isn't it? Points uh, are like this. Now, if I want to separate two classes over here, how what will I require? I will require a point or a line. So I require some line, isn't it, to separate certain groups. So over here, we are having two-dimensional representation because we are having two features. But to separate, we are requiring one-dimensional line. Can you see this? So for two, if you are two features, you are dealing with two dimension and you are requiring this kind of a geometrical representation. But to separate two classes, you require one dimension feature, one dimensional line to separate. Okay. And if you are dealing with three features, you are dealing with three dimension like height, weight, and age. So you are having height, weight on this x-axis, height on the y-axis, on the z-axis you have got age. Now, how do you separate two groups over here in this three dimension? To separate two groups in three dimension, you need a two-dimensional plane over here to separate this three-dimensional space. तो थ्री डायमेंशनल स्पेस में अगर आपको दो ग्रुप्स को सेपरेट करना है तो आपको एक टू डायमेंशनल चीज लग रही है जो कि है प्लेन. So thus, if you are having n dimensional, if you're dealing with n dimensions, you're having n features and you're dealing with n dimension, then you require n minus 1 hyperplane, n minus 1 dimension hyperplane. So this is what was said in the previous slide. Do you get it? So what is a hyperplane? A hyperplane is a n-dimensional space. In an n-dimensional space is a flat n minus 1 dimensional subset of the space that divides the space into two separate parts. A line is a hyperplane in two-dimension space. A plane is a hyperplane in three-dimensional space. A point is a hyperplane in one-dimensional space. Okay. This is what is a hyperplane. So, what is the definition of a hyperplane? Consider n-dimensional vector space R raised to n, the set of all vectors x arrow, x1, x2, x3 till xn in Rn whose components satisfy an equation of the form this. This is the equation. So, what is this equation saying? That if you are having features x1, x2, xn tak, so there is some constant, isn't it, before it, and then there is a Say if it is a line, suppose you have a intercept and you have a and b are two coefficients, isn't it? There are two coefficients which are scalar, actually scalar values. So over here, this is a maybe an intercept, you can say, and these are various slopes. So what is this? All x alpha 0, alpha 1, alpha n are all scalar values. And if you have to represent, now this is going from alpha 1, alpha 2, so on, isn't it? So you can just represent it as this way, alpha vector. Okay, even x, the features that you are dealing with, x1, x2 till xn. So you can just write it in a short form, x and a bar over it, and a arrow over it. This is an equation of a hyperplane. Now, in your books, at times, this coefficient is written as b, and this is written as w. So there is one and the same. Somewhere they are using alpha, somewhere they are using w, somewhere they are using some different alphabets to represent. Okay. So this is how what is an hyperplane. This is a common equation for a hyperplane. This is how you represent a hyperplane. Which separating hyperplane to use in this kind of a case? There you have got some data which is linearly separable. मतलब इस तरह से डेटा है, कुछ इस तरह से अगर मिक्स होता डेटा तो आप लीनियरली सेपरेबल तो नहीं होता ना वो. So we'll see an example. So how do you separate these two? So there are two groups of data and the data points are separate enough that you could draw a straight line on the figure with all the points of one class on one side of the line and all the points of the other class on the other side of the line. If such a situation exists, we say that data is linearly separable. So there are kinds of data. There is a linearly separable data and there are data which are not linearly separable. So suppose if you are dealing with linearly separable data, then how do you separate this data? You would want to draw this particular line. You may choose from all these particular lines, isn't it? To separate this linearly separable data. So if these are the clusters that are there with us, now you could have made this line to separate these two clusters, or maybe you would have made this particular line, or you could have made this one. Which is the one that would be the best? In fact, that would be the best. Suppose if if I choose this particular line, what happens? Suppose there is a red point that comes. Now these are the data that is I'm having. Suppose a new data that comes which is falling over here. If it is falling over here, now we are going to put that particular point in the blue cluster because the line is over here in the blue cluster. But suppose if we have this line and this point is lying over here, right? So what we would have done, we would have put it in the red cluster. So how do you decide on what is the best line to separate? Huh? And this is an example of a linearly separable data. So if you draw a line, you are able to separate this data. But if you have this kind of a data, then you are not dealing exactly. This is not these are examples of data that aren't linearly separable. So the hyperplane is our decision boundary, isn't it? You have to now. What is we are only talked about a line. What is a hyperplane? Is something more than just a line, okay, which includes margins also. Okay, so a hyperplane is our decision boundary. Everything on one side belongs to one class and everything on the other side belongs to the different class. We'd like to find a point closer to the separating hyperplane and make sure that it is as far away from the separating line as possible, and this is known as the margin. So if you take this particular example, how do we really draw a line over here? So we see that the point that is occurring over here, this should be far from this line, isn't it? So we have to choose that particular line. So that is what it is saying. So we'll have to identify a margin. So we'd like to find a point closer to the separating plane and make sure that this is far away from the separating line as possible, and this is what is a margin. So we have to find all other lines which are away from the separating line, which will make a margin to it. So we want to have the greatest possible margin, because if we make a mistake or train our classifier on limited data, we would want it to be as close, as robust as possible. So the example that I took, ना, this point, if this point is occurring over here, and अगर हमारी line ये वाली है तो क्या होगा, वो इधर चला जाएगा, और अगर हमारी line ये वाली है तो क्या होगा, वो इस red में आ जाएगा. ठीक है. So what are margins? Margins का idea क्या है? Select a separate hyperplane that maximizes the margin. So if suppose this is the line that you are considering, then what we have to do is, if we look at the points which are occurring away from this particular line, is this green line, green points ना, ये दो green points है और एक ये दूसरा डार्क पॉइंट है, तो इसके बीच में कोई पॉइंट्स नहीं है. तो हम एक ऐसी लाइन फाइंड कर रहे हैं जो कि इस मेन लाइन से दूरी पर है, जो कि ऑलमोस्ट नियर द क्लोजेस्ट पॉइंट, विच इज जस्ट नियर द क्लोजेस्ट पॉइंट. So this is what is the margin. Okay, this is now if you choose this particular line, ये line choose करते हैं हम, तो ये देखेंगे कि हमारे margin का width ज्यादा है. और अगर हमने ये line choose करी होती, ये वाली, तो ये दो points सबसे पास में हैं और ये जो point है वो सबसे पास में है, इसीलिए हम ये margin हो जाते हैं हमारे. तो हम ऐसी लाइन को चूज करेंगे जिससे हमारा जो मार्जिन है वो सबसे ज्यादा होगा. तो मार्जिन कैसे फाइंड किया हमने, ये जो लाइन हमने फाइंड की और हम इस तरफ बढ़ रहे हैं, वी आर गोइंग परपेंडिकुलर ऑन दिस साइड एंड वी आर मेकिंग अनदर लाइन विच इज टचिंग द क्लोजेस्ट पॉइंट. Okay, similarly over here also we are going perpendicular on this side and we are just touching the closest point. Over here also we are coming and we are touching the closest point, and thus we are making these lines, these two lines we have made. Now we see that this margin width is less, but this margin width is more. So we are supposed to select the hyperplane that maximizes the margins. तो हमारा जो hyperplane यही है, ये हम choose करेंगे क्योंकि ये margin को maximize कर रहा है. Okay. Now what are these points? ये जो points है हमने select करे हैं, they are called support vectors. Support vectors are those points in the cluster which are very, very near to the hyperplane. So this is my hyperplane and I'm just drawing a perpendicular to these points. Which point is closest to the hyperplane? I'm taking that and I'm drawing a line just near it, okay, on this side. Over here also I'm just taking, on this cluster also, I'm just taking a perpendicular and going to the point which is closest to my hyperplane. Okay, and thus I'm making these two lines which are parallel to my hyperplane. Okay, parallel to my hyperplane in such a way that the margins are maximum. So these points that you have selected are called support vectors. The points closest to the separating hyperplane is known as support vectors. Now that we know that we are trying to maximize the distance from the separating plane to the support vectors, we need to find a way to optimize this problem. Find the maximum margin. What are we going to do is, we are going to thus use the concept of norm over here and the concept of this line over here and just find the distance from each and every point to this particular line, and then we will just draw a margin lines so that we'll have maximum distance. Okay,